Trigonometry. Let's get tricky with it. Okay, let's go. So far, we've learned to solve for the missing sides of a triangle using the Pythagorean theorem. Pythagoras. Remember, Pythagoras said a squared plus b squared equals c squared. But Pythagoras only works when we have two things. At least two sides. Then you could find the hypotenuse. Or one side and hypotenuse, then you could find the other side. Hey, the equation has A, B, and C. You needed two of them to find the third. As an example, a builder is about to cut rafters for the roof of a house. The width of the house is 12 meters. Why not label that? And he has to make the roof 2.5 meters higher in the center than on the sides. You know what? I think that's saying that is that okay so far? Oh, and then it says the eaves overhang 0.5 centimeters. So that little distance right there is going to be 0.5, I said centimeters, 0.5 meters, half meter long. About yay long. Yeah, that's about right. I've seen houses. Find the total length of the rafter he has to cut. I think what they want us to find is that whole distance there. I can't find it directly. I think what I can find is that distance that I've just colored it in red, and then, Amy, I'll just add 0.5 to it to get the overhang. Why can't I find it directly? Well, we're doing trigonometry, which is the study of triangles. You can even see the same root word, trig, triangle. That little overhang isn't part of a triangle. I find a good strategy in this unit is whenever possible, Brody, to do a resketch. So really, I have a triangle that looks like this, where this is 2.5. What else do I know? Yep. Ah, nice. 6, not 12. If this was a provincial exam question and multiple choice, do you think one of the answers would be the answer you would get if you used a 12? Yeah. In fact, they'd probably put that as A. They think that way. And I'd like to find that. How can I find that? Well, Pythagoras. I can go a squared plus b squared equals c squared. What you have to remember, Garrett, with Pythagoras is the c is the hypotenuse, always. Which one is the hypotenuse? The long diagonal side. What's the hypotenuse in this case? X, so it's going to be the variable. The variable wasn't always there. We did some previously where there was a number there and you had to subtract. But yeah, it's going to be x squared. It's going to be 2.5 squared plus 6 squared. A and B, Brianna, there is no rule. You could have written 6 squared plus 2.5 squared. No problem. I'm going to get x squared equals, what is 2.5 squared plus 6 squared? I know 6 squared is 36. Calculator time, boys and girls. That's why I said you needed, one of the reasons I said you needed a calculator. What is 2.5 squared plus 6 squared? 42.25, he says, questioning. Yep. I'm right? Woohoo. Except, Amy, that found x squared. We don't want to find x squared. How can we find x? How do you get rid of a squared? Yep, square root. So now, if you didn't write this step in your homework or in your quiz, no problem. But Greg, since these are notes, I'm going to write x equals the square root of 42.25. If you went to your calculator for some of these steps and didn't show all this work, I'm okay with that. But in our notes, we'll show this. So it's going to be the square root of 42.25, which may work. Oh, holy smokes. Am I done? No. Because that wasn't what they wanted me to find. They wanted me to find L. I've just found the little red section there. How long is the overhang? How long is the red section? Ah, how can I find the total? $7 meters. Is that okay, Anthony? You know what? I would argue that's Math 9. Okay, it's a word problem, but I gave you a picture. If I give you a picture, I think word problems are a lot easier and not too bad. Who else needs a seating plan, or has it gone all the way around? Thank you, sir. Looks good. What we're going to ask now, Amber, is what if they don't give me two sides? Or one side and one hypotenuse. What if they only give me one side and an angle? We're going to get to that part actually on Friday. But for now, we need to be able to name sides. Every triangle has three sides. That's fairly obvious. Every right-angled triangle, every triangle that has a right angle, has three special sides. The first one is the hypotenuse. What would be a good letter to use as an abbreviation for the hypotenuse? H. We're going to do that for the rest of the unit. The other two, the hypotenuse is the slanty or the longest side. It's always across from the 90. It's the one that you're familiar with from Math 8 and Math 9, from Pythagoras. Jordan, the other two sides are called opposite and adjacent. What would be a good letter to use as an abbreviation for the word opposite? O. What would be a good letter to use for an abbreviation for the word adjacent? A. We're going to do that for the rest of the unit as well. Now, what's opposite? It depends. First of all, I have to tell you, Simi, what angle in the triangle is our frame of reference. But the word opposite means facing. Right now, Simi and I are opposite each other. Across from. The third side is adjacent. Which side is adjacent? Ashley, it depends. I have to tell you which angle is our frame of reference. But in English, the word adjacent means besides. You two are adjacent to each other. Beside each other. Okay? This allows us to label sides. Let me give you an example. I'm going to zoom in on example 1 here. Which one is the hypotenuse? That one is never going to change. It's across from the 90. Let's all of us put a little h right there. The length of the hypotenuse is 13. Now, we have a tradition in math for using certain variables for certain situations. As an example, don't write this down. If I see that, don't write that down. I'm pretty sure you're talking about a graph. You don't even need to show me graph paper. I'm pretty sure what you've given me is a point. Well, in trig, it's traditional, if you're talking about an angle, to use Greek letters. And the Greek letters that we use are alpha, which is a fish, sort of. It's where our letter A comes from. You can see it. You can write this down if you want to. Hey, what letter do you think in English comes from that? B. This is beta. We'll often use alpha. We'll often use beta. But the most popular one, the one that I'll almost always use unless the question does not, is 0 wearing a belt. Does anybody know what that one is called? This is called a Greek letter theta. We'll use alpha, beta, and theta. It's shorthand. You don't have to, Sam. You can use X's and Y's, but the questions, if I'm typing them, I'll use alphas, betas, and thetas because it's shorthand. When I see that, I go, oh, we're doing trig. Even if I don't see a triangle, I know we're doing trig. So here's alpha in this triangle. Adjacent means beside. Which side is beside alpha? Not the 13, that's the hypotenuse. Which side? That is the adjacent. Let's put a little A there. By the way, our English word alphabet literally comes from the Greek letters A, B, alpha, beta, ABCs. Oh, I didn't, yeah, you learned something new. Opposite, Simi and I are opposite each other, are across from each other, facing each other. Which side is facing angle alpha? 12. Let's put a little O right there. 12. And then put your pencils down for 1 second. What if instead I told you that this angle here was our frame of reference? 13 is still the hypotenuse, but which one is opposite to the blue angle? 5. Which one is adjacent? 12. So adjacent and opposite, Alex, it depends. I need to know which angle we're talking about. Hypotenuse always stays the same. Oh, we'll never use this one as our frame of reference because then the hypotenuse and the opposite would be the same, and that's confused. We'll never use the 90. It's always going to be one of the smaller angles. Pick your pencils up. Example 2. Which one is the hypotenuse? 15. Let's put an H there. Let's do the 2 betas, the bottom 2 first, and then we'll come. By the way, that there, hey, what letter do you think comes from that there? This symbol. What English letter do you think comes from that? Capital E, that's an epsilon, which begins with which letter? E. A lot of our alphabet comes from Greek. You don't need to know that, but nerd that I am, how can I resist, showing it to you? Let's do the betas first, because there's 2 of them. So here's beta. I tend to color in the angle we're talking about so it stands out, and because it's coloring. How often do we do that in math? Which one is adjacent to beta? 12. Not the 15, that's hypotenuse. 12. Which one is opposite to beta? Let's go look at epsilon, which is in the bottom right corner. Which side is opposite to epsilon? 12. Adjacent would have been the 9. You need to be able to, by Friday, label these in your sleep. If you get this, everything else that I do is grade 8 cross multiplying and memorizing a little rhyme. And Greg can certainly point out, do we use trig in physics like crazy? In fact, you're probably at the point where this for you is going to be boring review. And don't tune out, but try and, your challenge, sir, do as much as you can on your calculator showing no work, and I'll be okay because you've done a bunch of trig in physics 11. So we have 3 sides, opposite, adjacent, hypotenuse. We also have 3 primary trig ratios. Okay. I'm not going to walk through this. It's kind of cool, but I'm going to omit it. There are 3 primary trig ratios, and Jordan, they are defined. They are defined. The first one is what we call sine. It's a button on your calculator, but it's abbreviated. What's it abbreviated on as your calculator? Huh? Yeah, and it's sine, not sin. Calling sine sin is a sin. Sin is when you swear in my class. Sin is when you say sin instead of sine, and I will jump on you. Sine. And sine, its definition, the definition of sine is it's the length of the opposite side divided by the length of the hypotenuse. In other words, you guys stay on this page, the sine of alpha would be 12 over 13, opposite over hypotenuse. There's a second trig ratio. Cosine. And the third, abbreviated how on your calculator? Cos. And the third one is tangent. Abbreviated how? What Naomi was doing last week. It's opposite over hypotenuse. So, sine is opposite over hypotenuse. You need to memorize it, but I'm going to give you a great trick too, so don't freak out. Cosine is adjacent over hypotenuse. And tangent is opposite divided by adjacent. And I'll give you the way that for at least 300 years, English-speaking kids have been memorizing these three. We use an acronym, and the acronym is the word SOHCAHTOA. And in fact, what I'm going to tell you from now on in this unit, anytime you turn the page, the first thing you write at the top of the page is the word SOHCAHTOA, because it's the easiest way to memorize the word. What do you think the S stands for? Sine. What do you think the O stands for? Opposite. Over. What do you think the H stands for? It has the trig ratio contained in there. What do you think the C stands for? Cosine, which is adjacent divided by or over hypotenuse. What is tangent? The T stands for? Tangent, which is opposite over adjacent. And I still, when I think of trig ratios, that word pops into my head. Kids are always tempted to make up rhyming words with this, soak your toe or whatever. Do not, because what's going to happen, Amy, is you'll remember the wrong stupid rhyme and you'll forget the good useful acronym. I've seen it before, so resist the temptation. SOHCAHTOA. Opposite over sine, opposite over hypotenuse. Cos, adjacent over hypotenuse. Tan, opposite over adjacent. Now we have enough to be able to find the ratio. If I tell you the three sides of a triangle, you can tell me the trig ratio that goes with it. For example, example 3 says, find the indicated ratio in fraction form. Let's do the 3 betas first. So angle beta is down here. Let's color that in just so it stands out. Sine is what over what? Opposite over hypotenuse. So looking at that triangle, which one is opposite to beta? 5 over hypotenuse. 13. And it said leave it as a fraction, so I will. I could decimalize it. 5 divided by 13. Yeah, whatever. That's math 7. I'm not going to waste time on that. What would the cosine be? What over what?
Over
More specific. More specific. 12 over 13. Right? What would tangent be? Opposite over adjacent.
5 over 12.
5 over 12. Now, Brianna, if I look at a different angle, that's all going to change. Because now it says look at angle E, angle epsilon, if you want to use the Greek. So, okay. It says, what's the sine of epsilon? That's going to be opposite over hypotenuse, but what's opposite to epsilon?
Well,
I'll change colors. I'll color it in red. 12 over, what's the hypotenuse? 13. That one doesn't change. What's adjacent? What's beside epsilon? Now, a lot of kids are, hey, Mr. Dueck, isn't the 13 also beside epsilon? Yeah, but the 13 is always the hypotenuse. The across from the 90 is always the hypotenuse. So adjacent means beside or touching. What's the only side that's touching epsilon that we haven't used yet? 5. Oh, wait a minute, Mr. Dueck. You guys are looking like I did this wrong. The first one is cosine, isn't it? I should have read the question. Cosine is adjacent over hypotenuse. Which one is adjacent? 5 over 13. I'm sorry, folks. That was dumb of me. I should read the question. So used to going sine, cos, and tan because that's the order that it appears on your calculator. The second one, Alex, what's the second one they want me to find?
12 over 13.
Sine, which is going to be 12 over 13. And the third one is tangent, which is opposite over adjacent. Oh, what's opposite? 12. What's adjacent? 5. Is that okay, Brady? How many of you have seen this before from last year? A few of you? Okay, so the rest of you is going to be cold turkey, no problem. So far, so good. Try filling in the next 8. Find that, you know what? This kind of repeats for some dumb reason. I guess I forgot to change this on my original. So you know what? Let's make this cos. Let's make this tan. And scribble out the last line. There, do I have sine, cos, and tan? Sine, cos, and tan? I do. Try filling these in on your own. And I'll have to remember to change my lesson for next year. Sine is opposite over hypotenuse. Can I zoom in? Not quite. Maybe. Nope, let's go to 150 times. Cos is tan is you get on vibrate, but you can still power it off. Do you get in the first column 15 over 17, 8 over 17, 15 over 8?
Mm-hmm.
And in the second column 15 over 17, 8 over 15, 8 over 17?
Mm-hmm.
Okay. This is not the useful part, by the way, Sam. This is actually boring and a waste of time, but I have to start out with this to first of all, the key is, can you label the sides? Do you understand the difference between an opposite, an adjacent, and a hypotenuse? Turns out, now for years, until probably your great-grandparents, trig was done by hand with charts. But one of the first things when they invented calculators, one of the first things that they did is they programmed the calculators with trig tables. It turns out that your calculator has the sine and the cosine and the tangent programmed in, Garrett, for any angle. Turn the page. If we wanted to find trig ratios, one way would be to draw a triangle that had the appropriate angle, measure the proper sides, measure the opposite and the hypotenuse, and then divide and get an answer if you wanted the sine, etc. That's time consuming. We can used to use charts. In fact, when I was in high school, all my exams still had a trig chart attached because not everybody had a scientific calculator. Yes, I'm that old. But you folks all have calculators with sine, cosine, and tangent buttons, and you have no idea how thankful you should be. However, it is possible that your calculator might be in the wrong mode. We will be doing our math in degrees. How many degrees in a circle?
316.
360. Okay. You can also measure angles in radians. There are 2 pi radians in a circle. You can also measure angles in gradians. There are 400 gradians in a circle. And they all have different uses. But here in high school Math 10, we need to be in degrees. So you want to look on your calculator screen right now, and you want to see if you can see a little letter D somewhere up there along the very, very top. What you don't want to see is an R or a G. Now, if you're not sure, we're going to find out, because example 4 says, find the appropriate trig ratio in decimal form to 3 decimal places. We're going to find the sine of 30 degrees. On most of your calculators, what you are going to do is press the sine button, type 30, and then press equals. And if you do that, you should get 0.5. Now, if you've got a crappy calculator, and I've yelled at you all year, you might have to go 30, then press sine equals. Who cannot get the 0.5? That means you're in the wrong mode. I will now come and fix those. I said to 3 decimal places, except 0.5 works out evenly. Find the cosine of 15 to 3 decimal places, please. You get 0.966? Find the rest of these, C, D, E, and F. Try these on your calculator. I'll do them up here. Let's see if we get the same thing. Make sure you round off properly. I got B 0.966, I got C 1.428, D 0.035, E 1 exactly, and F 0.966. Okay. So what does that mean? Let's look at the first one. You guys can stay on your screen. It says the sine of 30 degrees is 0.5. The sine of 30 degrees is 0.5. And okay, this is taking way too long again. Let's see if it'll open this time. There we go. If you were to build a triangle with a right angle, and this angle here was exactly 30 degrees, the ratio between this opposite side and this hypotenuse is exactly 0.5. In other words, if you knew that this was 6 long, that's 12 long. Has to be. Or if you knew that this was 3 long, that's 6 long. Or if you knew that this was 1.8 long, this is 3.6 long. This is why trig is useful. These ratios don't change, so if you know the angle in one side, you can figure out the mystery side. What was the second one that I gave you? Was it cosine? Cosine of what?
15.
So a 15-degree angle is pretty small. Probably about like that. Cosine is adjacent over hypotenuse. What was the ratio? What?
0.966.
So if this is 0.966, this is exactly 1 long. And otherwise, these are yuckier numbers. I'm not going to do the 1/2 is a nice one. I can do that one in my head. But that's why we have calculators to do this for us. Not only that. Not only can I tell you the angle and say, you give me the trig decimal, tell me the angle, give me the trig decimal, tell you the angle, give me the trig decimal, tell you the angle, give me the trig decimal. We can go backwards. I can tell you the trig decimal, and your calculator can give me the angle. This is all stored in. Going backwards, to find the angle, what you have to use is the shift or the second function or the inverse button. In other words, If I tell you that the sine of the mystery angle, I don't know the angle, is 0.0523, you go like this on your calculator. All of you try this with me. Second function or shift sine of 0.0523. You should get an angle of 2.9 of 3 degrees. Now, if you're not getting that, now is the time to figure out how your calculator works, and I will come help you too.
What do we put in?
So, second function or shift. Okay. Which trig function did I give you in the question part A? No, which trig function? Sine, cos, or tan?
Sine.
Hit that sine. Give it the decimal answer. On your calculator screen, many of you will have a little -1 appear. That's the symbol for going backwards or inverse. So you go 0.0523. You're saying, hey, this is the answer I got. What angle did it come from? And your calculator should come back and tell you 2.997, 3 degrees. Let's suppose you went cosine and you got an answer of 0.978. What angle did that come from? B, second function or shift, cosine of 0.978. Close bracket. Some of you may not need to. Now yours, of course, you have to do everything backwards. You figured that out, yes? 12 degrees. Supposing I told you that the tangent was 0.625. Hey, what angle did that come from? $32? By the way, symbol for degrees is a little tiny O up there. Yep. You have to go? Can you wait 3 minutes or not? Okay, can you wait till 1? Yeah, let's do that. Really quickly, find D, E, not B, and F on your own, please. I got 89 degrees, 27 degrees, and I got 2.56, but it says to the nearest degree 2.5. I guess would round to 3 degrees. Okay. The very last skill that we're going to practice today, Garrett, is cross multiplying, which we've kind of been doing all year long, I think. It's when you have a missing side given the ratio of an angle. So, for example, let's suppose you were solving the equation sine 45 equals x over 10. What you really want to visualize is it's sine 45 over 1. Because you know what you have now? 1 fraction equals 1 fraction. You can cross multiply. You'll get x times 1, which is just plain old x, equals 10 times the sine of 45. Now, how would you type that in on your calculator? 10 times the sine of 45. Which is what? 7.07? What we're going to do is we're going to take partial pictures of triangles, write equations like this for the missing sides, and then cross multiply to find the actual missing side. Cos 31 equal, you know what? Cos 31 equals x over 4. That's cos over 1. When I cross multiply, I'm going to get x times 1. Ashley, what's x times 1 in your head, please, dear? X times x, thank you. And it's going to be 4.8 times the cos of 31. I'll just write that down, and now I'm going to go to my calculator and type in 4.8 cos 31. What is 4.8 cos 31? You get 4.11. They didn't say how many decimal places to go to, so if I'm not sure, I usually go to 2. Yeah, 4.11? No, yes? Sam, yeah? Okay. By the way, what's the difference between C and A and B?
You're going to have to divide the 10
Where is the X? On the bottom, okay? And yes, you were going a couple of steps ahead already, and that's great. When I cross multiply, I'm going to get ready, Ashley. 12 times 1 in your head, please. 12. I'm going to get 12 equals x times tan of 83 degrees. And I'm just going to write x tan 83 degrees. And I want to get the x by itself. How would I get the x by itself, Alex, my friend?
Divide by 12.
Divide by 12? No, that'll move the 12 over to this side. I want to get the x by itself. What else is next to the x?
Divide by tan 83.
I want to divide by tan 83, because what's the tan 83 doing to the x? Multiplying. How would I move it over? Divide. I want to get the x by itself. X is going to be 12 divided by tan 83. Try that on your calculator, please. And I think you get 1.47. Everything I've showed you right now, Brady, on its own is kind of useless. But as Greg can attest, actually we use trig all over the place, and we'll start doing some applications already next class. And if you take physics next year, you'll get really good at trig. And if you take physics 12, you'll do most of this showing no work in your head, because you just get, well, after you get done it 1,000 times, it gets pretty routine. For now, your homework, can you try number 1? That's very similar to an example that we did, writing the trig ratios. Number 2 is exactly the same as number 1, except it says write it first of all as a fraction, and then write it as a decimal. So once I have the what over what, then go to your calculator and just divide them, because your calculator will almost always give it to you as a decimal. So just getting you used to both. Garrett, yours did the 1/2, but most of the time it'll give it to you as a decimal. Okay? Number 3, very, very quick. Boom, 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 boom. Number 4, how is number 4 different than number 3? Okay, in number 3, I'm giving you the angle. That's just going to be hit the sine or the cos or the tan button, the angle equals. In number 4, there's 2 ways that I can show you you don't know the angle. I can leave a blank space there, which is kind of a dumb way to write it. You know what a better way is going to be? Like in G and H, I'll put a variable there. I'll say the cosine of A equals 0.6157. What's A? Still going to be second function or shift button. And cross multiply number 5. It seems like a lot, but most of it is plug and chug on your calculator. It should go pretty quick. This is not due Wednesday. This is due Friday, because you have a test upcoming. Thank you, Simi, for your patience.